Founded 6 decades ago, Custom Building Products is the industry leader in flooring preparation and tile and stone installation systems. We're the preferred partner of leading contractors, architects, and developers throughout North America. At Custom, your success is our success. Our goal is simple: exceeding the expectations of construction professionals every day. Our commitment to practical solutions and technical expertise helps you deliver installations that are as durable as they are beautiful. Custom's rich tradition of innovation has led to breakthroughs like the first polymer modified grout, pioneering lightweight mortars and underlayments, the original liquid waterproofing membrane, and a revolutionary single component grout. Trusted Custom brands offer complete installation systems that ensure high performance from a single source.
Before we get started, I thought I'd tell you a little bit about this program because it's a little bit different than what we normally do. Usually when we do a continuing education program, we take a single product or a single installation method and we really go into that in detail. This program is quite a bit different. One of the things that I noticed through the years as I went on complaints about tile and tile installations is that a lot of the times it was the same problems that we were encountering. Sometimes it was in the installation, sometimes it was in the design, sometimes it was in product specification, but whatever, it was the same problems over and over. So what I thought I would do is take a look at the most common situations where we see difficulties on job sites and try and work back and say, how could we have prevented this from happening? So we're going to touch on a lot of different subjects during this presentation. So I'm going to go fairly quickly because it is a fairly long one. This is an AIA and IDCEC registered program. For registering, you should receive a certificate of attendance. Some of the learning objectives that we're going to take a look at are the types of tiles that are available to you, the characteristics of those tiles, the types of grouts available to you, and design considerations that you might want to keep in mind as we go through these programs. One of the neat things about designing with tile in particular is that you have an almost unlimited palette to work with. You've got different textures, different colors, different styles, different materials. And that's a great medium to be able to use to put together. But in some cases, not all of the materials are installed exactly the same way. So I'm going to take a look at glass tile first, because glass tile is one of the more difficult products we have to install. And that's because of the characteristics that glass tile has. First of all, just like porcelain tile, glass tile is impervious. That means it doesn't absorb any moisture. And it's also usually poured in a molten form into a mold, which means that it's got a very smooth texture. That means that it's going to be difficult for our bonding materials to grab onto it. So we need a very strong bonding mortar. Another characteristic of glass tile is that it's very susceptible to thermal conditions. Let's say you've got glass tile in a shower and you turn on the hot water. That glass tile is going to want to expand very rapidly, sometimes more rapidly than the materials around it can absorb. So now we need a mortar that has some sort of movement to it. But here's the catch. With a standard cement-based mortar, the tendency is as it cures, it shrinks. So sometimes when you're installing a large format glass tile, like a 6x12 or something of that nature, the mortar is so strong, and then when it shrinks, it has a tendency to put pressure on the outside of the surface that can sometimes cause crazing. And often that crazing isn't really noticeable until they go to grout. So my first suggestion to you is when you have a large expanse of glass tile, I'm talking about an entire wall, a swimming pool, a shower. I'm not talking about the accent strip that sometimes occurs, but when you have a large expanse of glass tile, Every major manufacturer makes a glass tile mortar. But nowadays, you can also use any mortar that has a A118.15 designation from ANSI. That's a different kind of modifier to the mortar that uses calcium aluminate rather than cement, so it doesn't shrink during the curing process. Service rating is also another consideration. If you're using glass tile as a walk surface, the Tile Council has ratings for their different installation methods. However, if it's glass tile, it's not as durable as ceramic or porcelain, so the rating is exaggerated. So if it says it's light duty commercial on the installation side of it, then if it's a glass tile walk surface, it's going to drop down to residential. It's going to drop down one level. And then the other thing about glass tile that sometimes makes it unique, and this occurs with just about all kinds of mosaics, is the backing that's involved in the materials itself. Here's an example of a glass tile where it was simply the wrong tile was chosen. This is a Byzantine glass, and Byzantine is poured into molten forms. They're irregular in size and shape and thickness, and it's a great design medium, but it's not a good product usage on an outdoor walkway, as you can see here. One of the questions that will keep specifiers out of problems is to find a sales rep that they are not, who's knowledgeable and gets back to you quickly, and ask them, can this product be used in this manner? I can't tell you how many product problems would be avoided had that question been asked. Here's another one that has kind of an interesting switch to it. This is one of the cases where the standards don't really encompass what's going on here. The first question that I usually get asked when I show this is, why in the world will the contractor install this way? And my answer is that he didn't see it. Large format glass tile, and this is a 4x4 glass tile that's obviously translucent or clear, comes with a paper facing on it. The installer installs it, and if he doesn't get it beat in properly, so he's got full coverage of the mortar on the back of the tile, he won't see that until he wets that paper down and peels it off the surface of that tile. My suggestion is, when you have a clear or translucent glass tile, make sure somewhere in the instructions that the contractor back butters each piece of tile. That's where he takes the flat side of the trowel, puts a thin layer on the back of the tile, and then combs it into the wall as well. That way, if there are any irregularities or gaps behind it, it won't show through the surface. And I said that this one was an unusual case because here's the situation we have looking at it. The most important concern we have with our bonding mortars and in installations is, how much coverage are we getting on the back of the tile? In other words, how much of that bonding mortar is actually touching the back of the tile? In a dry area, that has to be at least 80% according to ANSI standards. In a wet area, that has to be 95%. Well, this is 95% mostly. So it's a case where the standards don't encompass the installation itself. But again, if you have them back butter the tile, that should not be a problem. Now we talk about backing on mosaics, and it shows up on glass tile, it shows up on porcelain tile, it shows up on natural stone as well. And obviously the reason for mounting these tiles on a sheet is to allow the installer to install, usually it's 1 square foot or 1.5 feet on each sheet as he goes. But remember, we're still looking for 80% coverage on the back of the tile and in a dry area, and 95% coverage in a wet area. If I was asked to install this tile, I wouldn't be afraid of it, because as you can see, there are lots of openings in that mesh that allow us to embed the mortar into it and get a good firm bond on that tile. But here's the catch. Not every manufacturer uses the same mesh system or the same adhesives. For example, here's another type of mesh, and you can't see it too well, but look at the middle tile on the left-hand side. You can see that there's lighter and darker variations to that particular tile. Well, that darker variation that you're seeing on the screen is actually the adhesive that was used to mount those tiles to the sheet. Now, our mortars can't touch the back of that tile to hold it in place. So one of the things that you have to do is you have to increase the bond strength of the mortars that you're using to make sure that you're getting a stronger bond where possible, because otherwise the installation that you're looking at is dependent upon the strength of that mesh to the tile, not to the mortar to the bonding surface. So increase the, and again, this would be a 118.15 mortar, or in some cases, it might have to be a 100% epoxy bonding mortar. And we'll talk about that in just a minute. Here's another situation that we sometimes run into, and the first question that I usually get on this slide is, why do they have two different meshes? Well, if you look closely, these are square edge tiles. And by doing this double mesh system, it makes sure that no matter how they move the sheet, the tiles remain spaced appropriately for the grout joints. However, can we achieve a 95% coverage on this tile using, where we get the bonding mortar is touching the back of the tile? And the answer is no, we can't. So again, increase the bonding strength of the mortar that you're going to use to accommodate the fact that we can't touch as much of the tile as we would like. And here's the worst case scenario. If you look in the bottom right-hand corner, you'll see a shine there. This often is a off-color white or a cream color. And in this particular case, the manufacturer is using a resinous-based material to attach the mosaics to the sheet that you see. And we can bond to that all day long, but it takes another resinous material, which in our case is a 100% solid epoxy bonding mortar. Our traditional cement-based mortars don't bond well to resins. Now, the reason this is important is because of the cost differential. Cost differential is for a standard cement mortar, even a high performance cement mortar, the contractor is probably going to pay in the neighborhood of 25 cents a square foot for it. If he has to go to an epoxy bonding mortar, his cost on that material alone it could be over $1 a square foot. In addition, a lot of contractors feel that mortars are harder to work with, epoxies are harder to work with, and they charge a premium for labor. With the new modern mortars that we have, that really shouldn't be the case, but a lot of people have been burned over the years, and that's just the way they cover themselves. So if you're looking at a situation where the samples that you look at has that cream color and it has kind of a gloss to it, the question you need to ask is, can I use a traditional cement-based mortar to install this tile? If the answer is yes, then you're home free. If the answer is no, well, then do you have the additional money in the project to afford what could be a $1 to a $2 increase in the cost of installation? That's not something you want to learn on an RFI. Natural stone is another product that sometimes gives us some difficulty. And that's because there are so many different types of natural stones. We kind of make generalizations in a lot of cases. And everything that we talked about in terms of backing for mosaics can also occur on full-size pieces of natural stone. It's typically one that has more veining because the veining is actually impurities in the stone, and it's the weakest part of that stone. So they put a mesh on the back of a full-size piece to make sure it doesn't crack, again, during installation and transit. So again, look for the type of backing and what color it is and how it's attached. The question you need to ask is, can I install this using a traditional mortar? That's the question that will keep you out of trouble. Travertine is another very popular stone right now. And here's my analogy. We're going to take a big block of Swiss cheese and we're going to cut a slice off the end of that Swiss cheese. Well, there are air pockets through that Swiss cheese. In some cases, you're going to hit one of those air pockets right in the middle, and there'll be a divot on one side and a divot on the other. When that occurs, the fabricator will fill that in with either a resin or an epoxy material. It's typically referred to as fill. If you see a piece that has a lot of fill, that could be a warning sign, because here's what can happen. Let's say on that slice, we just miss one of those air pockets. There's a little thin eggshell covering over that air pocket that we can't see. Well, that may not even show up during installation, but it very often shows up when it's put into use. So here's my caution here. Make sure that the end user understands what's going on here, because that's not a defect in the installation and it's not a defect of the stone. It's a characteristic of that particular type of stone. It's not unusual to have to go back to the project and fill in those spots as they become popped up and frequent. So it's just something everyone should be aware of when they're selecting that particular type of stone. And shading is another issue that you have to be careful of. Make sure that the material that you're looking at actually is going to be what you can get on the job site. And the best way to do that is when you're asking for samples. Number one, I ask for at least 2 or 3 different samples of the same natural stone. And if it's a shaded stone, you want the lightest shade to the darkest shade. If it's a veined stone, you want the least veining to the most veining. And the reason for that is because if you look at one piece, you may make a judgment that that works fine, but if you look at the extreme ranges, it may not work for you. And the other suggestion I have is to make sure it comes from existing inventory. Existing inventory will be respective of what they actually have, and it may vary somewhat from the sample boards that are put out and sometimes not updated as often as they should be. Service rating is also a key there. Natural stones have different compressive strength and different structural strength and breaking strength. Make sure that the service rating for the installation matches the stone and that the stone matches the service rating for the service being intended. Again, this is where a well-informed sales representative can come in handy. This is the stone I'm planning to use in this fashion. Will this be acceptable? And here's a situation that we all hope to avoid. We actually have 2 different conditions going on in the same slide. The first is efflorescence. Efflorescence are salts and minerals that are present in concrete and cement. And as the moisture wicks out of that building, it's drawing those salts and minerals to the surface. Well, we can clean that with a sulfamic acid wash and get it to looking good, but it's not correcting the underlying conditions that caused it in the first place. On top of that, we also have the wrong product that was selected. In this particular case, the architect selected a Vermont stone that looked very similar to this, and the Vermont stone would have been very an acceptable use on an exterior like this. But here's what happened in this particular case. Someone got to the owner, a salesperson got to the owner and said, put a sample board of his material and a sample board of what was selected side by side and said, look, these are almost identical and I can save you, fill in the number on this particular project. Well, the owner didn't know enough to say, okay, what's the chemical composition? Because the stone that he was choosing from had a very high iron oxide count. And as we all know, when you add water to iron, it rusts. That was the situation here. Had they gone with the original selection, it would have been moot. But the other thing that should have been done in this particular installation is that all exterior installations require a waterproofing membrane. That stops the moisture from going in either direction. That wasn't obviously done, and that's what allowed the moisture to escape in the first place. Ceramic and porcelain tile are guided by ANSI 137.1, and it's for those different qualities and performance characteristics of those different types of tile. But what I thought I'd spend just a second on is the trim situation and how it can affect an installation. The photo on the right is one of those situations where, excuse me, I'm not sure what they were thinking, because it's a through body tile, which means the color is consistent from the top of the tile to the bottom of the tile. And he made a cut. He just needed to flip that around to put the cut edge next to the grout joint. He would have been fine. But instead, he left it exposed. Noticed that there was a slight difference because of the cutting effect, and decided to paint it. Not a wise choice. A piece of bullnose would have been very nice, or even a metal transition piece would have been a much better option than trying to paint it to match. And here's a case where they did an awful lot of this use of trim correctly. Number one, they're using a cove base. A cove base is a base piece that comes down, rounds out, and meets the tile head on. In a lot of cases, this is required in food service areas. And the reason for that is that if you take a mop along that cove base, the mop will actually ride up and it will clean that out completely. Had that been a straight wall down to the floor, there's an edge in there that you can't get to unless you use something like a toothbrush. So they did that correctly. Then they used an outside corner to member the two bases where they come together. Again, that's a good use. Not only does it have an impact on the appearance, but it also makes it a much sturdier situation, because porcelain on that rounded edge is harder to chip than the edges that are exposed above it. But what they didn't do is they didn't continue with trim in either a metal transition piece or an actual bullnose piece on that wall going up, because it would have taken that grout joint from that huge grout joint that you see down to the grout joints that are on all of the other tiles that you're looking at. So it would have been a much more professional installation. As the tiles became larger and larger, we started dealing with issues that we didn't have to in the past. And one of those is warpage and lippage. And one of the first things that we noticed is as the tiles got larger, particularly pressed tiles, they were typically just a little bit thicker in the middle than they are on the ends because of the way the press and the pressure that it was applied. And what we were getting when there was a 50% offset or a brick joint pattern was you're at the high point of one tile and the low point of two tiles. So one of the changes that ANSI made is they said when the tile is more than 18 inches on any one side, you can't go more than a third of the way into the next tile with that grout joint, because it minimizes that high to low transition. So that's one of the most important changes that they had to make, along with the flatness of the substrate. Metal tiles can create their own bonding problems. And the reason for that is just like, there are different kinds of tiles, there are different kinds of metal tiles. There's a manufacturer out there who takes a porcelain body and wraps it in metal. Well, we're essentially installing a porcelain bodied tile, and we do that all day long. That's not going to be a problem. But there's another manufacturer out there that takes a resin body, pours the metal filings into it, puts it into a mold. The metal is heavier than the resin, so it sinks to the bottom. They let that cure, and then they polish the surface when they take it off. However, we learned earlier that resins are hard to bond to. Well, in this particular case, I'm going to say go back and ask for the manufacturer's recommendations, because they are all over the board when it comes to metal tiles. I've seen some say always use epoxy, never use epoxy. I've seen some say use a standard cement, mortar don't use a standard cement mortar, and one manufacturer even recommends using liquid nails as the installation material. So ask the manufacturer's recommendations. They should know how best to install their products. And here's an example of a metal cover piece and then a metal cap. Thin tile. Manufacturers have been on this quest to make tile as large as they can, and they've succeeded in making tiles that are 5 foot by 10 foot in size. They're much thinner. It's made with a different manufacturing process, but it's a tremendous design material that designers are frankly crazy over. It's particularly good for an exterior application because of the size of the unit. It resembles a natural stone, for example, when it's in place. Now, one of the difficulties we had when we first started encountering these was how to install them properly. Well, thankfully, ANSI published in 2017 ANSI A108.19 and 2.0, which are the installation guides for exterior and interior installation of these thin tile panels and slabs. And the materials themselves have their own standalone standard, 137.3, which tells you how uniform they have to be, the breaking strength, and etc. So you now have the ability to just specify when you have large panels on a job, those particular ANSI standards, and it covers both the installation and the material itself. Makes it a much easier product to specify from that regard. And this is a great picture. This shows you the coverage that you need to get on these thin porcelain panels, and it actually shows you how how effective it can be. There is a technique to it. We have training videos on that, and we sometimes do training schools for the installers. But the fact is, it's not installed the way a traditional tile is. So make sure if you've got thin panels that are being installed on a project, that you have someone who has experience with that particular type of material. Because I can promise you, if they try and install it the same way they've installed everything else, it will fail because it's just not the same kind of product. Size of tile, large format tiles. ANSI, when the larger tiles started making their appearance, had to come up with some standards. And the first thing they had to decide what is a large tile? And their definition is any tile that has 15 or more inches on one side. So a 16-inch by 1-inch accent strip is a large format tile, according to that definition. So we have to treat that differently than we would anything else. The biggest change with large format tiles was that the surface had to be flatter than we were used to. Up until the advent of these larger tiles, the standard requirement for flatness of the substrate was 1/4 of an inch and 10 feet. Well, with these larger tiles, because tile doesn't bend, it's a hard surface material, that has to be a lot flatter in order for the installer to be able to work efficiently and effectively and avoid lippage and with the tile itself. So it's now half of that, or it's 1/8 of an inch and 10 feet. And I don't know how many job sites you've been on, but I don't see very many installations that meet that without some kind of remedial work. It should be expected that if you're using a large format tile on a walk surface, that there's going to have to be some kind of remedial work in order to get that to the flatness that's required. Now we're dealing with mosaics. Well, we've been dealing with those for quite some time. That doesn't pose too much of a problem for us. And the wood planks style. And one of the things I will tell you with the wood plank style is that they have a tendency to bow quite a bit. This is where a case where the spacers that actually clamp down and provide a certain, a pressure until that bonding mortar has a chance to cure are invaluable. I would require the use of spacers of a mechanical type of one type or another. There's several different methods out there if you're installing a plank tile that's porcelain. Different thicknesses. This is something that comes up when you've got an accent material or even different patterns as it shows there. Be careful when selecting materials to go with each other. Make sure that the thickness is similar or make accommodations for it. For example, if you've got an accent strip around a major body of the tile, uh, it's easier for the installer to install the base body and then work with the accent pieces if the accent pieces are the same thickness or thinner. Now, if you reverse that, if the accent pieces is thicker, then he's got a lot more labor to install the basic floor that it's going around. Those things need to be taken into consideration. You need to make sure that the accents materials that you're using work together cohesively. And then if you're looking for different patterns like you see here, select it from the same manufacturer, from the same line. They will make sure that they work together, as the photo on the left demonstrates. Those are all different kinds of patterns there, and it's because it's from the same manufacturer, the same thickness, predominantly working together. And there we're showing just some grouting techniques. Slip resistant. Dynamic coefficient of friction is an extremely important part of any tile installation. And if it's important during the design process and the installation process, it's important to know what that floor has to do. And that's been made easier because the Tile Council has come up with ratings: interior dry, interior wet plus, exterior wet, and oils and greases. They should indicate which of their tiles fall into which of these categories. Makes it easier from a product selection standpoint. Now, to make it even easier, they've developed these criteria for you to kind of give you an idea of what they mean by interior dry. In this case, it's in indoor shopping malls, hotel lobbies, office buildings, and showrooms. Interior wet, meaning probably intermittent wet, not a constant wet, would be entry foyers, public restrooms, grocery stores, front of house dining areas. Those are all areas that could get wet on an intermittent basis. Interior wet plus would include wet areas like public showers, interior pools, locker rooms, covered exterior areas. We know those are going to get wet. Exterior wet are pool decks, patios, walkways, and sidewalks. And oils and greases, as you might expect, are primarily either in automotive or restaurants where you're exposed to a lot of grease and or automotive fluid. So these will help you determine which category the tile that you're selecting falls into. Now, I'm going to tell you about something new, and I'll tell you why here in just a second. In 2020, the International Association of Plumbing and Mechanical Officials adopted a new provision in their Uniform Swimming Pool, Spa, and Hot Tub Code. And this is the first standard that requires a specific dynamic coefficient for inclined walkways. Everything else is the DCOF formulas that you see are based on a level surface expected to get wet. Now we're talking about an inclined walkway, and they've developed a formula for determining what that dynamic coefficient of friction should be. And this is the formula. And I have no idea what this is saying, but we have a lot of very smart people in our lab, and I sent this to them. And what they did is they developed a cheat sheet for me where I can put in the angle of slope in degrees, and it will calculate the dynamic coefficient of friction the surface needs to have. And they're starting out at a 0.42 minimum, so it's going to go up from there. And I used this sheet and I did some calculations. A 1 in 12 slope is about the most that the Disabilities Act will allow. Well, that slope plugged into the equation that you're looking at comes up with a 0.64, I think it is, minimum DCOF. So if you've got an outdoor ramp that has tile on it, that has an incline, then it's going to have a tile that meets that 0.64 minimum. And the reason I'm pointing this out is that right now it only applies to pools and hot tubs. But every time I've seen a standard that was duplicatable, that was objective, it's been incorporated into other standards. So I expect that you'll see this in other standards as this becomes a little bit more prevalent. I think it's a great way for determining, what tile should be used for the safest walk surface on a walkway. There are a lot of different choices for you in grouts out there available today. One of the most common is ANSI 118.6. That's a standard cement grout. It's great for joints wider than 1/8 of an inch. The high performance cement grouts was an improvement over that grout, and it did two things. Number one, it could be used in joints anywhere from 1/16 of an inch to 1/2 an inch. And that required the installer to just have one grout on the job rather than one for small joints and one for larger joints. A new variation has been the premixed or single component grouts. These are various base components, acrylics, urethanes. They're easy to use, they're stain resistant, and they're ideal for narrow joints. And then the old standby, the old grout that was considered bulletproof to some extent was the 100% solids epoxy grout that met ANSI 118.3. This gave you the strongest grout joint and the most stain and chemical resistance that was available at the time. So let's look at the 118.6 grout. It was a mixture of cement, fine sand, and water. Most of the time it was mixed with whatever was on the job site, and the color was dictated by the sand or the cement colors. It's one of the reasons the gray was the most predominant color back then. Pigments weren't added until quite a bit later. The first generation of latex additives were added to both sanded and unsanded grout versions, and these came in a milk jug. It looked like a jug of milk. When it was added to the proper percentage to the dry materials, it improved physical strength, color retention, and lower water absorption. However, the latex was the most expensive part of that installation. And some contractors figured, well, maybe I can water it down a little bit and make it go further. Well, that affected both the color and the strength of the material itself. So in the next generation, we used spray dried polymers instead of the liquids, and we add those at the factory, so that now all the contractor has to do is add the proper amount of water, and he has the product that using as it's designed to. High performance cement grouts, because it uses calcium aluminate rather than cement, doesn't develop the capillaries that cement sometimes does. And that's the reason that high performance cement grouts can really make an impact, particularly on exterior installations, on efflorescence. The efflorescence doesn't transmit through that particular chemical bond. So if you've got a porcelain tile and a high performance cement grout meeting ANSI 118.7, you've got a good combination that's not going to allow efflorescence to damage that particular installation. Pre-mixed grouts are the newest variation that we have. And in my opinion, pre-mixed grouts are as close as we've come to the perfect grout. It's highly stain resistant. In some cases, it outperforms epoxies. There are no sealers required because the stain resistance is built into the chemical composition. It's antimicrobial grout, so it's going to help repel microbes. And it's actually the only grout that we have that can be used. And if it's not completely used, it comes in a plastic container. It can be sealed up and has up to a 2-year shelf life. So you can actually reuse that material later. With all of the other different types of grouts, whatever you mix has to be used at that time or thrown away. So it's a much more effective grout. And it requires no water. It's very, very color consistent. And the reason for that is the color is determined by the manufacturer. It's not up to someone mixing it on the job site. One of the biggest problems we had with grout for years was color consistency. And that's because different people were mixing up the water usage in grouts differently. Contractors kind of like their grouts to be soupy. Well, that's fine, except that it changes the characteristics in both color and strength. So when they add the proper amount of water, it was fine, but they often overwatered it, which changed it somewhat. And then from person to person mixing the grout, there can be subtle changes too, which can affect the coloration. The premixed grout takes all of that out of the equation. And then we have 118.3 and 118.15 epoxy grouts. Epoxy grouts have traditionally been used in commercial kitchens and hospitals. They're highly chemical and heat resistant. They're usually 2 or 3-part systems, and they can also be used as mortars as well as grouts. Now, these are very specific areas of use, and you have to be careful which type of grout you're using, because in some cases you may need what they call an industrial grade, IG grade epoxy grout, which would fall under the closer to the 118.5 characteristic. The industrial grade is made to resist a higher concentration of the materials that it's going to be exposed to. And one of the things that you have to worry about with epoxy grouts, for example, is what's the cleaning regimen, particularly in fast food areas. Fast food areas often use a cleaning agent called an enzyme-based cleaner. And the way this cleaner works is they mop a thin layer of this cleaner on the surface of the tile, and it actually attacks the grease and food residues and breaks it down. But when it breaks it down, it forms oleic acid. That oleic acid, because it's attacking organic materials, can actually attack the epoxy grouts and soften them to the point where they're not effective. In one case, it softened it to the point where a broom would actually scrape it out of the grout joints. If you know that they're going to be using an enzyme-based cleaner in a situation like that, you need to go to the IG variation of that grout, the industrial grade, because it's designed to withstand that increased acid exposure. Grout joint size, sanded or non-sanded? Well, non-sanded was used from a 1/16 of an inch to an 1/8 of an inch. Sanded was from an 1/8 of an inch to a 1/2 an inch. There was a difference between the floor and wall. And then we also had to be careful about polished tiles, because if you had a wider grout joint with a sanded grout and a highly polished tile or stone, the sand in some cases could scratch the surface of the material. So you had to be careful. Now, we talked earlier about ANSI making some standards, had to revise some standards because of the larger grout joint or larger tiles that we were using. And here's another change that they made. As we were making these tiles larger and larger, we were making the grout joints smaller and smaller. And ANSI realized that there was a point of diminishing returns where the installer actually couldn't couldn't execute a grout joint successfully because of the tile he was installing. So they came up with a standard, and the standard is the minimum size grout joint on any particular project with any particular type of material is 3 times the actual facial dimension variations of the tile being installed. Well, that cleared it up, didn't it? Well, here's what it means. Let's say we're going to install 12 by 12s. Not all 12 by 12s are going to be the same size. You take the largest and the smallest that you can find on that project and you measure the difference. Let's say it's a 1/16 of an inch. Then 3 times that variation is going to be 3/16 of an inch. That's the smallest grout joint that contractor can be expected to execute on that particular project. The difficulty comes into play when you say, okay, well, how do you know that up front? Well, you don't oftentimes. So here's my suggestion. Most manufacturers are now giving you a recommended grout joint size. Don't go below that. Use their recommendations. They know what works with that particular tile. It will save you a lot of grief because you as the designer are the ones that's acting to actually design this. And if you go below that standard, that 3 times the variation, you might be responsible for any warpage or lippage that occurs. Rectified versus non-rectified, the smallest grout joint that anybody can be expected to execute, even with rectified tile, is a 1/16 of an inch. And rectified tile are tiles that go through an additional process during manufacturing. After they're pressed, they go through a grinder that grinds 2 edges, it flips the tile and does the other 2 edges to make each tile as uniform as possible to the next one. And again, the smallest allowable grout joint, even using a rectified tile, is a 1/16 of an inch. And in other cases, that standard of 3 times the variation applies. And I saved the worst for last, or the best, I don't know. This is the one that gets us into more trouble than anything else that we've talked about, and that's movement joints. I've talked to a lot of different forensic tile consultants, and the first question they're going to ask on every project is, show me your movement joints. Because most of the time, if there's a problem with the floor, it has to do with a lack or not enough, or sometimes in some cases not any movement joints that the tile requires. Now, there's 2 types of movement joints. There's movement joints for the tile itself, and then there's construction joints, which are bridging differences in the substrate itself. It could be as easy as concrete pours on 2 different days. There's a joint there that in that particular case, if it's in the construction itself, that joint has to come all the way through that assembly with a soft or movable joint. It can't be moved to one side or the other. It has to come up at that particular point. Now, the movement joints within the tile work, you have some latitude. The requirement for movement joints in tile work is every 20 to 25 feet in any direction. So if you've got a 50-foot by 50-foot lobby, you should have an X or a cross, making that into 4 different quadrants to allow for movement to take place, and even slabs on grade move, to allow that movement to take place so that there's no damage done to the tile installation itself. And the expansion joint that you see on the left is fairly common. It's one of the more common types of expansion joints. Construction joint on the right is showing you how it can come up, and this is showing you a saw cut joint, but it could be any type of construction joint, and showing you that it has to come up through that, and it has a membrane on either side to allow that material to have some movement without doing damage. Generic, there are very different types of movement joints. There's generic, expansion, control, construction cold joint, perimeter joint. Perimeter joints is one of those that we often see left out of installations. Anytime you have a change in plane in movement of tile, there should be a soft joint. For example, how many change of planes are there in a typical shower? Well, there's one around the perimeter of the shower, and then there's one up each wall. And if the ceiling is tiled, there's one around the ceiling. For some reason, contractors often leave those out, and it's not according to the standards. It needs to be done. Movements are needed because these things are going to move regardless of how solid they feel and how strong it feels. They are going to move. Even slab on grades, as I mentioned, will move on occasion. And when it comes to exteriors, the movement joint frequency increased, as does the size. Movement joint frequency on exteriors are every 8 to 12 feet. That's pretty close together. And the minimum size movement joint for an exterior installation is 3/8 of an inch. It can go larger than that depending on the temperature changes of the installation and the material being installed. But that's the starting point for exterior installations. And here we have exterior walls. What you see on the right hand side as a result of the movement that took place on the left hand side, you can see how it bowed out. And when that bowed out, that's a cementitious backer board. And by the way, on an exterior application, a cementitious backer board is required. The other type of backer boards are not suitable for exterior installations. So make sure that they're specifying the right type of backer board. But what happened is they didn't allow for any movement joints. They butted these sheets together, and because the building settled and gravity took its toll, it bowed that that backer board out. And as you can see, it popped all those tiles loose. That's the reason that we have movement joints that frequently on exterior installations. That plus the fact that obviously exterior installations are going to be more susceptible to thermal conditions. If you've got a dark tile on a sunny day, it's going to heat up tremendously. So, these are the conditions that we have to make allowances for when we're developing the movement joint system. And by the way, just to make it clear, the placement of movement joints is up to the design professional. I'll say that again. The placement of movement joints is supposed to be done by the design professional. A good contractor, if they're not included on the plans, will come back and say, hey, here's where I'm planning to put them. But it's not really his area to do that. It's the design professionals are required to do that, because you know what your pattern is supposed to look like, and etc. And these are examples of how you can execute movement joints in irregular patterns. It can be done, but it's for the tile work movement joints only. It's not for construction joints that we talked about earlier. But these are just different examples of how a non-linear joint can be affected. And it can be done very successfully, and that's a great thing from a design standpoint. Lighting. This has pretty much nothing to do with the installation, and yet we get a lot of calls dealing with lighting. And these 4 photographs show it as well as anything I've ever seen. On the left, we have wall wash lighting, where the lighting is directly against the wall and it's coming straight down. On the photographs on the right, it's the same installation, but all we've done is move that lighting out about 1.5 feet. As you can see, the difference is remarkable. This happens to us a lot on school work, where they don't have the lighting installed, or it's installed after the fact, And they say, well, this can't be done to standards. Well, there's nothing wrong with either of these installations. It's the lighting that exasperated the condition that we were looking at. And this, as you can see, the smaller the unit, the worse that lighting is going to make it appear, because it's picking up minute differences between the tiles as it goes through. And grout joints are typically concave a little bit, and it's accentuating the edges of those tiles. So that's a design issue. It's not an installation issue. The other consideration I have is when you have to tile a column or slope to a drain, I implore you, please use the smallest tile you can stand. Because when you try and use a large format tile sloping to a drain, contractors can get creative. They have to make it conform to the slope, which is 1/4 of an inch per foot. So they have to cut these tiles. And sometimes they do a halfway decent job of it. Sometimes they don't. But the fact of the matter is, there are things that can be done to help this situation. Number one, the use of a square drain by itself will improve the look of the cuts rather than a round drain. But the other thing that I would stress to you is that if you're trying to use a large format tile in a situation with a drain, consider a line or linear drain. That's a drain that you can put against any wall, and all we have to do is make sure that the surface slopes to the proper degree to let the water and soap film evacuate that surface. We don't care if the tile is flat. We don't care that if the tile is level. We care that the tile is flat. In fact, there are a couple instances, sloping to drains being one of them, exterior balconies where we don't want it to be flat. We want it to slope away from toward the drain or away from the building. So consider a line drain if you're trying to use a large format tile in combination with shower situations that have drains. It'll make it a much more, theoretically, you could use a 5-foot by 10-foot piece of porcelain panel and have a single drain along one wall, and you'd have no grout joints. So just consider that when you're thinking about how to incorporate those drains. The drains make a big difference. This is the diagram for showers and steam rooms. This is also the diagram we use for walk-in, roll-in showers. And as you can see, it's got a slope to the drain. This is incorporating an integrated bonding flange. That's a particular type of drain system that does the best job of keeping the moisture closer to the surface without exposing it to any underlying materials. Be careful, not all waterproofing membranes are approved for steam rooms. Make sure that it meets the PERM rating required for steam rooms. Check the manufacturer's information, ask the question, I'm thinking about using this installation materials in a steam room, is it okay? Because that, we've seen, actually, one of the photographs that I sometimes use shows a steam room where they used an adhesive rather than a cement-based mortar, and it liquefied, the steam liquefied the mastic, and everything just kind of slumped off. So it's important to use the right materials for steam rooms and showers. Make sure that it meets the ratings for both. The last thing we're going to talk about is maintenance. And it's one of the areas that I think is often left off of discussions, but it's the one that's going to be very beneficial to the end users of this project. Preventative maintenance. There's 2 times when the tile work is going to need protection. The first time is when it's first installed on the job site. It's going to need to be protected from the other trades. One of the most difficult situations we have is where drywall dust gets into a freshly grouted floor. It's very, very difficult to get that out of the grout joints successfully. So it needs to be covered appropriately to make sure that the other trades don't do damage to what was already installed. The other time it needs to be protected is right before it's put into use. And you have a lot of different options available to you. But when we talk about protection, you want it to have make sure that it has a quality of soaking in, absorbing into the material. We don't want a topical protection because that wears off. You want it to be absorbed into the material. Cleaning is another issue that can sometimes come up, and that's sometimes difficult because it's usually done by a cleaning crew. The cleaning crew may use chemicals that aren't compatible with what our grouts in particular are using. We talked about, enzyme cleaners on epoxies. What we want from an everyday cleaner is as close to 7 on the pH scale or neutral as possible. Now, if we've got situations where we're trying to correct a problem, we may use something that's a little more acidic or a little more alkaline. But for everyday use, we want something that's as close to that 7 pH as possible, because that will allow the cleaning to take place without doing any particular damage to the materials, particularly the grout joints. Okay, we covered a lot of ground in a very short period of time. There's my contact information. If you have any questions, please feel free to give me a call or send me an email. I'll be happy to help any way I can.
You can see why Custom is installed on more commercial and residential projects than any other brand. Count on Custom, your partner in flooring preparation and tile and stone installation systems. To learn more, visit CustomBuildingProducts.com.